Here are some small things I didn't cover in this series, some helpful resources, and then a few challenges for you to try out. The first two are very nice for quality of life. The $ symbol is the address of the current instruction, so in the following example, the program would be stuck in an infinite loop. While that's not very useful, it definitely helps a lot when combined with the equal instruction. This instruction lets you define constants. This lets you create a constant that contains the length of a string by subtracting the address of the previous string from the address of the current instruction. Note that while you normally use values defined in the data section by accessing its value in memory, constants are not stored in memory, so you just use their label. In this series, I've used local labels many times, but I never explained exactly what they do. Local labels start with a single period and allow you to repeat the same label multiple times in different subroutines. This works because the assembler replaces local labels with the previous global label concatenated with the local label. This means that you cannot have two local labels in the same subroutine. Macro labels are similar to local labels. Because macros copy and paste their contents, if a macro contains local labels and is called twice in the same subroutine, there would be multiple occurrences of the same local label in the subroutine. Macro local labels start with two % and are unique in each macro call. The last thing is command line arguments. When you assemble your program and run it, you can pass in arguments that can be accessed in the program. At the beginning of your program, before anything is added to the stack contains the arguments in reverse order and then the number of arguments. You can retrieve the number of arguments by popping from the stack and then loop through each argument starting with the first argument. Here are some important resources. If you search Linux system call table Chromium, it should pull up a website with a chart that shows all the syscalls and links that describe each one. Because we're doing 64-bit x86 on Linux, the first chart is the one you should use. When you are stuck, the thing you should do is look at the docs on NASM.us. If you can't find what you need or it doesn't make sense, you can then comment on one of my videos and I will be happy to help. Otherwise, you can often find people asking similar questions online, but many times it's not the same assembly language or it's for a 32-bit CPU. Finally, here are some challenges for you to try. The first is converting strings to integers or vice versa. It might sound easy at first, but it definitely can be challenging if you're new. Something else you can try is reading and writing to a file. You could also try making an SOLang compiler. There are many SOLangs out there, and they range from very simple to very complex. Good luck! Subscribe if you like the series, and stick around if you'd like to see some projects later on.